Turn on the computer and then press the switch from the back of the unit to the position on. As the unit is recognized by the laptop, 3 of the 4 LEDs on top right side of the spectrometer will turn on. After a few seconds, the scan LED will start blinking regularly. It indicates the interferometer is correctly rocking and ready to scan. Double-click on the GEMO FTIR icon on the computer's desktop. Once the software starts, a window will appear giving the operator 2 options of work: connecting the spectrometer or working on the software without having the GEMO FTIR activated. The latest option is useful when it's necessary to work only on spectra already stored. Click on Connecting GEMO FTIR. Now the spectrometer is ready. The GEMO FTIR can operate by 2 sampling techniques: transmission and reflectance or specular reflectance. In the transmission mode, the stone is crossed by the infrared beam, while in the reflectance mode, the beam is reflected by its surface. Here you can see the schematic views of the 2 methods. On the left, the transmission mode, which uses a modified sampling setup created for the diffuse reflectance. The infrared radiation coming from the source is reflected by the ellipsoid mirror towards the stone. It crosses it, and it's reflected upwards by the golden sample stage. The ellipsoid then focuses the beam on the detector. This is the most used technique, and it's practically always adopted unless the stone cannot be crossed by the infrared radiation. On the right side, the specular reflectance mode. We can see the beam following the same path, but this time the stage is lower to allow the ray to be reflected by the surface of the stone. Generally, this technique is used for opaque stones only. We will explain this method in details in the video number 5. Let's see how to perform the background and absorption scanning by using the transmission method. Before to proceed with the scan, it's necessary to check if the sample stage is at the correct position. The unit is provided by a micrometric adjustment of the sample stage height to allow different techniques to be used. The height can be modified by turning the knob just behind the sample chamber lid. Click on the Adjust button. A window will open displaying on the left the actual scan process and on the right the instructions for the height adjustment. The aim of this operation is to have the highest value displayed on the left side of the spectrum. Let's start gently rotate the knob to see if the signal improves. If it goes down, let's turn the knob in the opposite direction. A red line on top of the spectrum indicates the maximum value reached for that height, and it will move up as long as turning the knob will make the signal improve. When the maximum is reached, continuing to turn the knob will make the spectrum decrease, while the red line will remain fixed to the maximum value. Turn slightly the knob in the opposite direction till the spectrum will reach the red line again. Now the signal output gives the best performance and the unit is ready for the operations. There will be no need to repeat this procedure unless a change of the sample stage or scanning technique are required. Click on Stop. Click on Autoscan. The most typical and used one is the absorption spectrum, which is suitable for nearly all transparent gems. A faceted stone must be oriented on the sample stage table down. The second type, the transmission spectrum, is essentially the same as the first one, but the results are expressed as transmission percentage of light instead of absorption. The third method, the specular reflectance, can be used for opaque materials which do not allow the infrared beam to travel through them. The beam is reflected directly from the surface of the stone, so the sample needs to have a relatively flat, polished surface. Because each sample is differently sized, it is essential to adjust its height for getting the best reflectance signal from the surface. This makes acquiring specular reflectance spectrum some way more difficult than the other 2 methods, but with a little practice it's easily adoptable and a very powerful technique. However, it should be kept in mind the specular reflectance and absorption spectra are not equal, and sometimes not even similar to each other for a given gem species. Click on A to get the absorption spectrum. The Autoscan wizard will start by recording the background spectrum. This is the pure spectrum of the infrared light source, but it also contains some absorption peaks due to the atmospheric artifacts in the sample chamber, water or carbon dioxide. The background spectrum is measured multiple times and averaged. This enhances the signal-to-noise ratio or quality of the spectrum. The resolution default value is 4, which is enough for most of the gemological acquisition needs. Let's open the sample chamber and put a polished diamond table down on the sample stage. Click on Continue. The unit is now recording the absorption spectrum of the diamond. A preview of every single scan is shown on the left. At the end of the process, the resulting averaged spectrum is displayed. The scan can be even operated manually. The technique or experiment can be selected in this menu. Let's run absorption. Then click on Scan Background for recording the background spectrum. Now, let's put the stone on the sample stage and close the lid. As a last step, click on Scan Sample. Since the background spectrum can be essentially influenced only by the environment conditions like humidity and carbon dioxide concentration, usually is not supposed to change in a matter of a few hours. If the operator workflow includes a number of scans in that time frame, it will not be necessary to run the background more than one time, and the samples can be tested by clicking only on the Scan Sample button. This will save lots of time and could be critical in case of parcel testing. Contamination. It's always advisable to clean well the stones before to start testing them. This is even more important when we are using an FTIR spectrometer. Fingerprint oil contamination, in fact, can show up in the spectrum as two peaks at 2850 and 2920 cm-1, even if only minor traces are present. If those minor peaks can be essentially ignored while testing diamonds and other stones, they can easily confuse the operator and give incorrect results when testing emeralds for impregnation treatment.
Thank you for watching this video. For more information about our spectrometers, please visit our website. And if you have any question, please don't hesitate to contact us at info@gemoraman.com.